Hi, everyone, and welcome to AI with Ash. This is a podcast dedicated to philosophical insights into artificial intelligence, and I am your host, Ashmini Pereira, and I'm very, very excited to talk about today's topic, which is the early history of AI. Now, it's important to note that artificial intelligence as a term didn't come into fruition until the 20th century. However, we've been rational creatures who can dream and imagine things for a while. And so there have been stories all the way back from the Greeks, the myth of Talos, one in which the Greek god of being of blacksmiths and craftsmanship, Hephaestus created Talos, which was a bronze automaton machine that flew around the Greek island of Crete, defending it from invaders, transforming, heating up, throwing heated up rocks and all of this stuff. And this was an early insight into the way that we viewed autonomous machines that were able to have a purpose that could benefit the creator of said machine. Now, in this case, the creator was a god, but in the case of AI, these creators are both you, I, and anyone else who uses said technology. So, pretty interesting thing that this dynamic came up all the way from the Greeks, but history is important. As Hegel once said, we learn from history that we do not learn from history. So, all of the industrial revolutions of years past might give us some insight into how we can tackle the challenges of the current AI revolution. And with that, let's jump into the 1800s. We're going to be traveling back in time, the 19th century, an age characterized by massive, fierce social and political movements like women's suffrage, the abolitionist movement, as well as expansive European colonialism in Africa, Asia, and the Pacific. And for the purposes of this podcast, the Industrial Revolution, a flourishing renaissance of feats of engineering in science, technology, and math and everything. And I'm super excited to jump right in. And I think it's interesting that when we talk about AI all the way back, obviously there have been AI winters, but I wanted to do these deep dives to also present a point that I'll discuss in a later episode regarding what's called singularity. And that is this idea that technology, the rate at which it innovates now, is increasing exponentially. So now that we've started in the 1800s, we're gonna then go on to the 1900s and we'll see how much technology innovates. And then the early 2000s, the 2010s, to now, we'll see this massive increase at the rate at which technology has advanced. And I hope that doing these deep dives will not only set a foundation of the scientific and the historical background of artificial intelligence, but we'll also see singularity work its way through as I kind of go over what's happened in these years. So with that, let's jump right in. And we got a really good one. I remember when I learned about this in school, something just got my gears going because it was always my first question. What was the first computer? And here we have the Babbage engine in 1820, created by Charles Babbage. Babbage was the only child of the son of a very angry banker in London, and he studied mathematics, and he had this amazing imagination, one that allowed him to conjure up the Babbage engine. A couple different variations he worked through, one of which was the difference engine. And this was a way of revolutionizing calculation by mechanizing it. He wanted to be able to produce polynomial calculations that were error-free, and that the engine was automatic, and he did just that. He was able to use these punch cards and these rack and pinions, and mind you, this was a time where binary hadn't come about yet, so that he was just working in decimal. Also, he didn't end up, he built a small fragment of an engine he never finished, but the larger engine at play, these would have been on steam, not even electricity, because electromagnetism wouldn't have really been institutionalized until later. but he was able to show a small fragment to some of London's intellectual society. And we're talking about some big names, specifically big Charles names as well. So Charles Darwin was there, Charles Dickens was there, Charles Lyell was there. All the Charleses were gathering around this machine, taking turns cranking at it, and they saw that it worked. And later, some of Babbage's ideas, all of which were done on pen and paper, and some amazing feats of the imagination, all on pen and paper. And I highly recommend anyone who's interested in computing or mechanical engineering check these out. He had finalized his final set of drawings in 1846 for the Difference Engine 2, which he would never end up building. A, because he was a massive perfectionist. B, because he had trouble communicating with the government. But his son would later go on to help. His son Henry would later go on to build some of the engines, as well as museums later. So his legacy lived on, and it also lived on through the first computer programmer ever. She is Ada Lovelace, and Ada Lovelace was under Babbage's tutelage. He was her mentor, and he taught her the ropes. I'm like, he taught her the ropes and the ins and outs of his machine, and she would later go on to interpret it as and give her own visions on it, as well as build a computer program that was able to calculate Bernoulli numbers. I mean, how cool is that? And not only is Ada just this sick programmer, but she was also the daughter of the Lord Byron, the poet, the Lord Byron. Now, she never really met her father, but her mom and Lord Byron split, and her mom was super distraught by Byron's inwardness when he wanted to be art and his artsy and his you know how the artist types are. But so her mom was like, no, Ada, like, no art or literature or anything for you, strictly math, logic, all of that. And that was her domain. That was what she stuck to. And it ended up being great because she made massive feats of mathematics, and she's the reason why we program today. So really cool stuff. And she was also tutored by Augustus De Morgan, who would go on to create De Morgan's Law also in the 19th century, which gave massive contributions to set theory, which, you know, helps probability. And AI is completely just a probability distribution at the end of the day. Although I'm not the biggest De Morgan fan, although his law is quite easy. I did like his law because it was one of the easier ones, but I think De Morgan himself was rather sexist. He once said that mathematics was too difficult attention for women. And then he was like also tutoring Ada Lovelace, who is like the biggest boss of all time. Also, shout out chess.com for having Ada Lovelace in your Women's History Month, because I played her and it was one of the best games ever. So love ya, Ada Lovelace, real you, and your chess version as well. Similar to De Morgan in the realm of logic and probability, George Boole was also up and coming at this time. He was the founder of Boolean logic, which would end up becoming the foundation of logic gates in circuitry and logic just in computers, AND gates, OR gates, NAND, NOR, XOR. All this fun stuff that kind of guides our computer organization today was George Boole. So when we have like Ada Lovelace, Charles Babbage, these creators of really the first computer, those would be the people who would later, a century later, influence Alan Turing, who would become the father of theoretical computer science. And it's interesting, actually, the Babbage engine is a Turing complete problem because it has arbitrary memory and it has conditional statements in the form of if statements. So very cool stuff going on in that realm of town. I think it's cool how they all like knew each other too, because I'll talk about Charles Darwin as well later. So it's interesting how some of like these existentialist thinkers always like know each other. I mean, the Fitzgeralds knew the Picassos, or just like, it's cool how like fun people always know each other. Anyway, we're gonna move on to another person I think is really cool and kind of underrated in his era, but that was German physicist Hermann von Holtz. Hermann von Helmholtz. Yeah, quite a mouthful to say, but he had major contributions to chemistry in the form of energy conversion. He contributed to works in Euclidean geometry. He was known for his work in neural the way in which neurons fire and how fast that goes, nerve conduction velocity. He had work in color vision, sound perception. So like I mentioned, AI is such an interdisciplinary field when we think about text to image, text to video. So we need these data sets that, or the ability also, not just the data sets, but the ability for a computer to recognize certain patterns. And these patterns exist in images. These patterns exist in sound. And the way in which it learns emulates that of a brain. So the way that the nerve impulses and the speed at which they go could contribute to the understanding of how well a neural network should go in order to maybe meet the level a human is at, or if we're talking superintelligence, then supersede a level at which a human is at. So maybe that would involve increasing the velocity of a neural network's equivalent of nerve conduction, and we wouldn't be able to do that if it wasn't for Helmholtz. But also just the conservation of energy, that's just foundational for the study of computational systems. Like I said, interdisciplinary, this is a machine with logic, and it's inspired by biology, and it requires energy to go, so it's all of these different fields of science are able to create contributions that eventually allow them to have some like, I don't know, like a stake in the game of artificial intelligence. Hermann von Helmholtz, now this is a philosophy podcast as well, was also very into the idea of consciousness and what it meant to understand history and what the desires of our minds came from. And he would pit Kant and Hegel in some of his work, and he would really think about those philosophies. So I thought it was interesting, and I wanted to share this one quote by his, and that's this: "Every great deed of which history tells us, every mighty passion which art can represent, every picture of manners, of civic arrangements, of the culture of people of distant lands or of remote times, seizes and interests us, even if there is no exact scientific connection among them. We continually find points of contact and comparison in our own conceptions and feelings. We get to know the hidden capacities and desires of the mind, which in the ordinary peaceful course of civilized life remain unawakened." So a really interesting idea about kind of the importance of understanding the world around you, as well as trying to seek the truth and not remain asleep, or I guess what he says is unawakened. So very interesting stuff from Hermann von Helmholtz, and his contributions not only to science but to philosophy are well received. Thank you, Mr. von Helmholtz. Next up on my list today, we got Michael Faraday. And he and Maxwell created the Faraday-Maxwell equation, which was able to predict the existence. And they were able to predict the existence of electromagnetic waves. Now, this was just a massive development in electromagnetism, which would help in the creation of transistors and vacuums and hard drives later in life, and all of these developments built on each other. But the Faraday-Maxwell equation was just opening the floodgates for so much new knowledge when it came out. And if anyone is interested in learning more about this, you can also take the rabbit hole down of string theory and look into Michio Kaku's God equation, because he references the Faraday equation as well with Einstein's theory of relativity. So it's an interesting combination there, of which a lot of work is still being thought about. So big discovery on that end. And not only did it help electromagnetism, but it would also later help the development of radio waves, and so there would be an uptick in communication technology. Something like the telegraph did come into fruition in the 19th century as well. So we saw a lot of great inventions come out of Faraday and the Maxwell equation. Yep. And then next I want to talk about Carl Gauss. So Carl Gauss gave rise to the Gaussian distribution. And what this is essentially a probability distribution. If you've probably seen it, it's just your normal distribution. It's a bell curve. And the Gaussian distribution is used to model almost every natural process. It's used in age, height, IQ, memory, errors, any type of error is usually a Gaussian distribution, and what it means is most of the data clusters around a central point. And then there are these tails, and there's different ways to then interpret the tails if you want to lengthen them or not lengthen them. But it's these Gaussian distributions that are then used to provide a closed form way to evaluate the Bayesian or the Bayes neural networks, which are specifically used in machine learning and artificial intelligent problems. So it's interesting to see that these Gaussian process probability distributions are used to describe the distribution over the predictions made by these Bayesian neural networks. So, Carl Gauss has a very significant impact on AI when you look at it through that lens. So thank you, Carl Gauss, for your contributions. I feel like I'm going down a list and I'm like, thank you. You're sexist. Thank you. Thank you. Next up, we have Charles Darwin, and I have a funny story about Charles Darwin. I don't think a lot of people are gonna expect this, but one of my grandfather's names is Charles on my mom's side. I guess I only have one grandfather on my mom's side. But on my dad's side, my grandfather's name is Darwin. So I always felt like I had this really strong connection to Charles Darwin because that was like the combination of my grandparents' names. We know Charles Darwin. Everyone knows him. Household name, On the Origin of Species. Went to the Galapagos, messed around with some finches, and he was able to come up with the theory of evolution and natural selection, that, we have inheritance, that we come from another species, which comes from another species, and we all have a last common ancestor, survival of the fittest, all of that good stuff. And this kind of led to what are used now in the sphere of artificial intelligence, but evolutionary algorithms, which are used for optimization problems, and then maybe fed into an adaptive system that are used for cybersecurity or I don't know, a million things, energy management, Internet of Things, autonomous vehicles. So I always think when we consider the relationship between biology and computers, it can sometimes be down to something like that, just evolution mimicking evolution on a computer. And Ray Kurzweil talks a lot about this, and I'll spend an entire episode talking about singularity, and I'm hoping these history videos will provide a lot of good foundation to that. But Ray Kurzweil talks about how people don't really see technology as an evolution, but it is. And the reason why we're going to singularity is because the rate of that evolution is increasing and increasing and increasing, and eventually there has to be a point at which we cannot see what's after that, and that is the singularity. And I just spoiled the whole episode, but we have a lot to unpack there. So yep, that was Charles Darwin and his theory of evolution. Also around this time there was binary that came about, so we went from the decimal system to a binary system of zeros and ones, which made computing a lot easier and a lot more efficient and a lot more logical, because now we can use the zeros and ones for true and false, and like Ada Lovelace considered that this is not just numbers are not just quantities, but they can represent other things as well. Yeah, and then as I mentioned, this was a time of immense philosophical thinking. We had really cool philosophers come up. There was Nietzsche, there was Marx around this time. Kant was still really relevant, and he brought this new idealistic philosophy. Yeah, I mean, a lot of cool philosophical debates were happening at this time as well, around the causality of things, and just the question of God, morality, the usual philosophy talks. But I guess I think I'll end off with some honorable mentions that I didn't really dive into, but so much was going on at this time that I wanted to really focus on what I focused on. But here are my honorable mentions, the first of which is photographic imaging processing. So The development of photography and early image processing techniques like chemical development, this would then just be a stepping stone in the realm of photography. And when we look at how far we've come with Midjourney and DALL-E, it's interesting to see that, just in the 1800s, 2000 years ago, like we were still just doing the same those old tactics, and look how far we've come. Yep. And getting away from images now to sound, we have Charles Wheatstone's research in acoustics. Helmholtz did quite a bit of physiology into the ear and understanding of acoustics, but it was Wheatstone's research in acoustics and sound perception that would then set a lot of foundations for later developments in speech recognition and audio signal processing. And this has been around for quite some time. We'll talk about Siri and more of the contemporary AI field, but the way speech recognition has evolved from the time of Charles Wheatstone to then maybe customer service, then Siri, then now with AI generated music, a Drake cover of a Lana song. So this was an important foundation when we consider these now text to audio models. And then finally, I'm going to get to text to vision. So this was Louis Braille's Braille system in 1824, and this gave a means for visually impaired individuals to have a way to access a written information system. And this would later inspire research in just accessibility technologies and natural language processing. And if you've seen the video on my main channel on the ethics of ChatGPT, I talked about how when ChatGPT came out, OpenAI came out with their API, there was just a whole generative AI explosion. Amongst them was a startup dedicated to describing the surrounding area for those who had visual impairments. So it's cool to see that this movement to create a tool to fit some kind of loss of function in our society still exists. Now we're moving from Braille to generative AI. So very cool to see that these use cases are still the same, but the technology has rapidly changed. So with that, thank you for listening. Now, next week, we have a very, very exciting episode called What Do Psychics, Genies, and Witches Have to Do with AI, where we'll explore the different use cases for an AI agent and see where they lie philosophically. And just like in a cool way, I guess. Anyway, thank you for listening. And I hope you have a great rest of your week, and I'll see you next episode. Goodbye.